Thank you. Thank you very much. So, day 2 session after lunch. I think I'll have your attention for about 5 minutes. I'm hoping to have it longer, but let's see. Let's see how it goes. So first of all, thank you for being here, and thank you for having me at this event. This is my first time in Switzerland, so I'm really enjoying it. And it's my first time traveling anywhere in 2 years, so you can imagine how excited I am. But you know, my holiday begins after the talk, so let's get to the talk and let's figure out what this is all about. All right. So first of all, okay, and right away I have a technical issue. Anyway, so first of all, my name is Abhay Bhargav. I run an application security company called V45. I also run an AppSec training platform called AppSec Engineer. In fact, I interacted with some of you, and apparently some of you are using it. Thank you for that. I started off my career as a offensive security person, right? Mostly pen testing, mostly apps. I've been in app security pen testing for a while. But then somewhere around 2015, 2016, my role kind of became a lot more about defense and scaling things and DevSecOps and cloud security, all of that stuff. And I've been doing a lot of work in this space. I've been training in this space. In fact, I train at Black Hat and so on. That's what I do. And of course, research is also a big part of what I do. This is actually, this talk is not a very typical talk that I would do. I'm mostly defensive security focused, but recently we came across this entire class of flaws. So I thought we'll talk about it in a pretty big way. I tweet a lot about educational content on my Twitter and of course on YouTube. If you want to check it out, you can. Now my talk, I'm not sure how many talks have this in here. I'm not sure whether that's a European thing or not, but there are a lot of memes in my talk. Okay, so there are a lot of memes, near nauseating number of memes in my talk. So better brace for it if you're a meme person or not. Can't help it. Anyway, so this is, my talk is going to have a lot of memes, and I have a live demo. And with live demos, it's always, you're always dealing with the demo gods, because everything could work and then nothing could work. So I do have one live demo, and I'm hoping it goes okay. So please pray for me before we get started. All right. So the agenda today, first of all, we're going to be talking about webhooks. Now, how many of you work with, know what webhooks are? Okay, most of you in the room. Great. I don't have to explain this concept too much. So webhooks are something that a lot of us know, some of you may not. I'm just going to do a quick introduction of that. We're going to look at common webhook issues, common webhook attack patterns. I'm not going to do too much of deep dive into that because there is one set of specific flaws I want to focus on, and that's really what we're all about. We're also going to quickly diverge into an area called SSRF. How many of you have heard of SSRF? Okay, great. Most of you in the room are not uninitiated, which is great. I'm happy to see that. So SSRF, we're going to do a quick, gentle introduction to SSRF, and then we're going to go back to a flaw that we call webhook boomerangs. And we'll talk about how these flaws happen, some of the cases in which we are able to talk about it. Many of them are under vulnerability disclosure process and stuff like that, but there are a couple of stories that I'm going to talk about, and then some subvariants of this, and finally the demo, right? So that's basically what I'm going to be doing today. So you're building an API, and not just an API, if you're building any kind of web applications today, you're probably using webhooks, right? Now, webhooks are a very common pattern, very common part of web applications today, and this is a great way to integrate your application with your customer application, right? It's a very common way of doing things. So webhooks basically are user-generated callbacks, right? So for instance, let's take a very simple example of a webhook. Whenever I get paid on Stripe, which is a payment processor, I'm sure all of you have heard of Stripe, used Stripe at some point in time, I can get a webhook. So Stripe can initiate a webhook to me saying, hey, you have been paid, or a new subscriber has been created, or a new payment has been created, right? Whatever. You are creating a user-generated callback. So in a webhook transaction, there are typically two parties. One is the provider, in this case, Stripe. That's the provider. And one is the consumer, which is my application, which is essentially getting that data from Stripe and consuming that data, right? So that's typically the provider-consumer relationship that we have. So in this case, in this example, I want to receive a webhook event every time a new user signs up to this particular, let's say my app, onto the provider app, right? So let's say I have this training management system or whatever it is, a new user signs up, then automatically a webhook is triggered and it hits my consumer application. So the provider triggers that webhook. It's typically a post request that hits my consumer application, and I take it in and do something with it. I store it in the database or do whatever I need to do, right? Some of the common traits of many of these provider applications, especially when they're dealing with webhooks, are that they store the results of the webhooks. I'm sure some of you have seen that. They store the results of whatever they send, and sometimes they do retries and they do all of that stuff, right? So this is a very common pattern. You can see webhooks are literally everywhere, right? From marketing automation to Kubernetes to Stripe to CI/CD systems, you see webhooks are literally everywhere. You see them as a very, very common occurrence all over the place. In fact, Zapier is a company that's built entirely off of webhooks. So you can imagine the amount of the impact of webhooks, the size of this whole scope that we're talking about, right? Now, webhooks are typically, these are the common traits, right? They're event driven, which means that when an event occurs, that's when a webhook is triggered, right? New user signs up, new subscriber comes in, new payment comes in, etc., etc. Or let's say something is deleted or something is modified. It's not always created. It's also sometimes on modification, on deletion, on blah, 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 right? It's typically event driven. So whenever that event happens, that's when you have a webhook that is triggered. Now, typically webhooks are post requests, right? Because you're usually sending some data, right? So when Stripe wants to trigger a webhook to me, they would say that, hey, this is a new payment that's come in from this customer from this region, and they would trigger a post request to my consumer application with some JSON payload. It's typically JSON payload. It doesn't have to be JSON payload, but it's typically JSON, right? That's what you see. And of course, your consumer uses that JSON to do something, process it whatever way it wants. Sometimes responsible webhooks add additional authentication and authorization on top of it, right? You're talking about HMAC signatures for authenticity of the message. They also additionally add API keys in the header to make sure that your application can verify that it is from a particular source and stuff like that. These are very well-known security patterns that you see. In some cases, provider systems, I've written producer, but it actually means provider. Provider systems also allow you to enter custom headers. So let's say you want a custom header to hit you from Stripe along with your webhook payload. They allow you to enter some custom headers and custom values as well, right? So you have all of these typical patterns that are going on so far, right? Have I breached the attention barrier, or is it still there? We still have attention. Great, perfect, excellent. I wouldn't have been able to stay awake past 5 minutes after lunch. Anyway, now let's talk about the natural webhook attack assumptions, right? Most of the time, I would be thinking on the lines of, can I attack the consumer, right? Most of the time. Is there a risk to the consumer? That would be my thought process. Can I compromise the consumer with some kind of deserialization, right? So I send it to the consumer and the consumer consumes it, and can I do some kind of deserialization there? Can I tamper with the payload, which is a whole authenticity problem? Can I tamper with it? You know, all of that stuff may be a consideration that you have. Can I do replays, right? Can I replay the same payload again and again and again, and will it work? This is a very common concern with webhooks as well. Can I attack from unknown sources? Can I figure out a consumer endpoint URL and keep bombarding it with some data from third-party sources? All of these are valid attack scenarios for webhooks, right? But we're not going to be dealing with any of this, right? We're not dealing with any of this. Instead, our focus is only going to be on one thing. Can I compromise the provider, right? Our focus is going to be exclusively in this talk on, can I compromise the provider? Is it possible for me to get the provider to get compromised because of something I do? And that's something that we are going to be exploring, and that's what we call webhook boomerang attacks, right? So can I do something like this? Which is basically, I have my provider, and behind my provider's applications are internal web servers, databases, what have you, right? My provider, let's say Stripe. Obviously, Stripe is going to have a whole bunch of internal infrastructure. It's probably hosting it on a cloud provider like AWS, so it has metadata and stuff like that. Can I, as a consumer, ensure that when a request comes in from my provider, can I somehow boomerang it back to the provider in a way that it attacks the provider, right? That's my objective here. As a consumer, so I'm on the red box side of the fence, right? As a consumer, can I do something that will get me to attack the provider back and get me some juicy details inside the provider's infrastructure, right? That's what I want to do in this class of attack. So that's really my focus in this entire class of attack. So this can only mean, of course, what? This can only mean SSRF, right? Now, oops, sorry about that. I'll deal with it later. Anyway, so SSRF is the attack vector that we want to use, right? SSRF is the attack vector we want to use because SSRF is essentially meant for these sort of situations, right? You are making the provider make a request because of some user-generated data that you have, right? So through a particular process, trigger a system where the provider connects back to their internal infrastructure and gives you the result of that internal infrastructure. Right? So that's basically what we want to do. So SSRF is, just for those of you who may not know what fully SSRF is all about, SSRF is a way where I, as the attacker, I'm trying to get the victim system to connect to an internal URL or some attacker-controlled URL or whatever it is, so that request can be made from the victim system to that URL, and the details from that request response is available to me, or I can get it, or I can fetch it, or whatever it is. Now, this is very commonly used for stealing cloud metadata credentials, right? Now, this has been used in attacks all over the place. It's been used in Capital One. It's been used in several breaches. I'm sure you would not find too many bug bounty reports where this is not mentioned. You have a lot of instances of SSRF. So you'll see that you have major scenarios where SSRF has been identified and successfully exploited. They've stolen cloud metadata credentials and used that to privilege escalate inside your cloud, be it AWS, Azure, GCP, what have you. You've been able to use that to compromise internal systems like getting access to Redis, or being able to access internal services like CouchDB, or internal systems, trigger actions on internal systems, and do all those kind of things, right? SSRF is a very well-known vulnerability that can do all of these things. You are getting the victim application to make a request internally or wherever it is, and give you the details of that request, right? Or the response from that particular request. So SSRF is used for a lot of these things. You can trigger a lot of these scenarios with SSRF. Of course, with the cloud coming into the picture and metadata being injected into most compute environments on the cloud, largely the focus has been on compromising cloud credentials, especially AWS, because in AWS, at least on the IMDS v1 variant, you can literally just make a GET request and you get the metadata and the credentials on 169.254.169.254/metadata, whatever, right? So you can do all of this stuff with SSRF. So what we want to do is to do the same thing to perform a successful SSRF, where we, as the webhook consumer, are able to attack the webhook provider. So in this case, the provider says, hey, you know what? New user signed up. Here you go. Sends a post request to my consumer, and my consumer essentially says, hey, sorry, you need to go somewhere else. You need to go to 169.254.169.254/metadata/credentials/ blah, 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 blah. And that's where the resource actually is. And your provider says, oh, okay, I'm going to go there, makes a request to that internal URL. And then, of course, you have SSRF that successfully converts to a privilege escalation once you gain access to those credentials. But there is one small problem, right? There's one small problem. Most of the time, you are dealing with SSRF when there is a GET request, right? SSRF is a classic attack where GET requests are involved. But your provider spits out a POST or a PUT request when it's making that webhook call, right? When it's making that webhook call, your provider spits out a POST or a PUT. That's typically what it's doing. So it's a little difficult because you need to figure out the right redirect for you to use. So that's where the HTTP 303 comes in, right? Now the HTTP 303 is a request, is a redirect code that is meant almost entirely for this. I mean, not meant for this, of course, but it's ideal in this particular use case because the way it works is that it is meant to respond to a POST or a PUT request. So when somebody sends you a POST or a PUT request, you can send them a 303 redirect and say that, hey, you know what? Redirect to this particular location, 169.254, whatever, and follow it. Follow that redirect. Whereas most of the other redirect codes do not require you to follow it. They require you to make a new connection, 301, 302, etc. 303 is beautiful because it doesn't require you to do that. It says, hey, go ahead and follow. Do this. You don't need to bother about anything. This is not there. Go. Right? And your application, being the nice kid that it is, does exactly that. Right? And what's worse is that most of the HTTP clients that you're using, I know for Python and Go, by default, they follow redirects. Has anyone seen that? They follow redirects. A lot of HTTP clients, I don't have the exact data of which HTTP clients do this, but the popular ones in Python and Go that I use typically follow the redirects. Unless you say don't follow redirects. By default, they follow redirects, right? So they just do that. So what we want is this. We've already seen how it works. It's going to make a POST request to our consumer. Our consumer says, hey, you know what? 303 redirect to 169.254, 169.254 slash metadata slash security credentials, blah, 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 blah. And then this says, okay, I'm going to call that. It'll receive that GET request. And then remember, webhooks, a lot of these provider applications store the results of your webhook requests and responses, right? They store the response result for you because they want you to have traceability, right? That's a good thing. Having traceability is a good thing. And they store the response. And you can just log into your admin dashboard on the provider and you get this beautiful response, which has AWS creds, blah, 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 whatever you want. Whatever your intent is to compromise at that particular point in time, all right? So you have that available. It makes a GET request to a metadata or to an internal URL with whatever it is, and then stores the result of that. Now, this is something that is not necessarily new. We've seen this in a couple of reports before, but it was clearly not as leveraged as it could be. Right? Not as leveraged as it could be. We've not seen this on too many new reports. So we started looking at targets with this, especially bug bounty targets. And we found a small company that I'm sure some of you know of. That company is called Docker. Right? Now, Docker, we essentially did this on Docker Hub. This was, I think, September of last year. So we use this on Docker Hub. So in Docker Hub, I'm sure many of you have seen this, you can set up a webhook, right? So whenever your Docker commit, you commit a container image to Docker Hub, you can set up a webhook, right? Now this webhook you can use for whatever it is. Right? So let's say you want to initiate a new build from a CI system or deploy it in Kubernetes or do whatever you want with it, right? Or create a webhook to AWS that will deploy it into a container on AWS or Azure or whatever it is. You can create webhooks on Docker. Right? So you can create webhooks on Docker, and we essentially wrote, in this case, it's just an example, it's not the same thing, but we essentially wrote a small piece of, we wrote a small web server Flask application on Python that would be our consumer, right? So we redirected all of Docker's webhook requests to our consumer, and our consumer would make a redirect to 169.254.169.254 slash metadata with the redirect code 303, right? This is something I already spoke about. So once we did this, initially and then we pushed a container image to our Docker hub, but we didn't notice anything. Docker was clearly storing our our data. It was storing the request or response from the webhook, but it was not really showing up on screen. Now, obviously, as super hackers that we were, we just did a view page source. Basically, we looked at the request going back and forth. And in one of the network requests, we realized that there was our role, our IAM role, our AWS IAM role was in the network request. It was not showing up on screen, but it was clearly getting returned as part of the JSON, as part of the webhook trace logs that you have. And once we got the IAM role from our webhook trigger, we were able to use that IAM role and then get the AWS credentials. And we reported this immediately to Docker, and thankfully for us, they fixed it in about 2 hours. So we reported it to their CTO, and within a couple of hours, they had a fix rolled out, and they were able to get this done pretty quickly. So this was pretty huge because behind the scenes, this was talking to their EKS. This was the privileges used on their AWS EKS clusters that was responsible for running Docker Hub. So you can imagine the supply chain element of this attack vector, if you will, right? Because that could have potentially snowballed into a whole bunch of other things. Thankfully, they were pretty good. They fixed it pretty quickly, and so they fixed it pretty quickly, and we verified that they had actually indeed gone ahead and fixed it. So this is a very common pattern. We see this with CI/CD systems all the time. We see this with a lot of webhook CRM applications, marketing automation applications, payment processors. Anyone that has a webhook functionality is potentially vulnerable if they're not doing a few things in terms of defense, which we'll get to in a little bit. Right? So I have a demo of this, and I'll just explain how that works. So, yeah. So in my demo is essentially going to be like, sorry about that. I thought I was mirroring screens. My bad. Just give me a sec while I do that. Or I'll just move this to that screen. Okay, that's fine. Okay, so in our case, what I've done here is I've not set up a metadata example here. I've set up an example where we have a CouchDB. How many of you have used CouchDB? CouchDB is a pretty simple key value store where you can store keys and values, and you can access it on HTTP. On HTTP, you don't need to use any specific library or SDK to be able to do that. You can just access CouchDB over HTTP just with GET requests and so on. You can use some POST requests, but for a lot of the select and list operations, you can just use GET request. CouchDB is pretty popular with a lot of applications that need to have basic key value functionality. So in this case, we have our application, which is the webhook provider, and we have consumer evil webhook receiver, and our consumer is going to redirect our provider to an internal URL, which in this case is CouchDB, and we're going to be able to exfiltrate some database information, some users, etc., from the CouchDB database. So that's basically what we are going to do. I'm just trying to figure out how to set up a mirrored display. Just give me a second. Hopefully, yeah. Okay, great. This is the first time I'm mirroring on this, so you can imagine how long it's been since I've actually presented. Anyway, so yeah. So this is just a test application that we've written just for this sort of stuff. So in this application, the way it works is that you set up a user. You can log in as the user. You can set up a webhook. Once you're done setting up the webhook, you can trigger an event. So it simulates an event trigger, and it's going to make a request to that consumer that you have. My consumer is going to be running in the same system here, and we're going to see how that works, right? So my consumer is running, my provider is running, we can see all of that stuff. So let's actually go ahead and see how this works. Sorry about that. Okay, so I'm going to have to copy paste some instructions, my bad. But so we have, I'm going to log in, I'm going to create an account as the user. So I'm going to create an account as the user. I'm going to log in as that user. So I'm just logging in and using the JWT access token and using that in the environment variable here. And I'm going to log in and check what kind of webhooks I've programmed as the user. What kind of webhooks have I set up as the user? You'll see that I don't have any webhooks that I have set up. Now I'm going to set up my first webhook. This is going to redirect me to my consumer on port 8088. So in this case, you'll see consumer on port 8088. It's going to set up that webhook. Now we are going to trigger an event. Now, if you look at my hook, you will see what I'm talking about. My hook is essentially redirecting to this environment variable called the redirect URL. In this case, the redirect URL is set to my CouchDB. So if you look at what's happening here, it's set to the CouchDB all DBs, right? So this is set up as my redirect URL. So now let's actually go ahead and run this. Let's simulate that webhook trigger event. So once we do that, once you simulate a webhook trigger event, it says done. Oh, sorry, I think I need to do one more thing. Just give me a sec. Yeah, I needed to generate some fake users, right? You don't want to just see a bunch of empty entries, right? So generating some fake users. So you'll see that it comes back with a base64 encoded response. Now, if you look at what this is, you'll see that it came back with it listed the tables from my CouchDB database, which is the users table. Now, if I want to retrieve all of the data sets in that, let's actually go ahead and do that. I'm going to change the redirect URL to something else. I'm going to say users all docs. So it's going to redirect me to this. So I'm going to start my hook and I'm going to trigger another webhook trigger event. This time it's going to come back with a whole lot of information because it's dumped my users keys in my webhook results, right? So now if you see, in fact, if you see our webhook results, it's obviously I said a lot of webhooks store your results, right? So let's look at webhook ID 1 and all the results it stored. You'll see that it stored the first one, which is the users table, and it stored the second one. And if you look at what this is, I would have normally JQ'd it, but I guess base64. So you'll see that it is able to retrieve the user's keys. Now, this is the same kind of pattern that plays out for your metadata as well, right? Same kind of pattern for your metadata, especially if it's on IMDS v1, which is AWS, which I'm talking about, okay? So this is a very common example of what can happen with this sort of an attack. But there is a slight variation to this, and let's talk about that for a little bit before we close the session today. So the variation essentially is, okay, it's AWS, and a lot of AWS customers are moving to IMDS v2, right? Which is the v2 of the metadata service, which requires you to do a put request, get a token, and then do a get request, and then do all of that stuff. So a lot of them are not on IMDS v1 anymore. What's the big deal? Why are you making such a big deal out of this? Is this really something that is that important? And yes and no. So let's talk about the yes part of it. The no could be, obviously, given your scenario, you might not have too much of an impact on this. But what about other cloud providers? What about Azure? What about GCP? Now, to access the metadata endpoints on Azure and GCP, what do you need to do? Anyone? Yes. Header, right? So you need to add a metadata header to your HTTP request, and you need to add some, Azure, or in this case, Google, or whatever it is, right? Now, remember, a lot of webhook providers or applications that deliver webhooks also allow you to confirm custom headers, right? They allow you to confirm custom headers, especially CI/CD systems, right? Because CI/CD systems are talking to a whole bunch of other things. They need to have API keys, etc., etc. They allow you to configure custom headers. So in this case, all you have to do is configure a custom header called metadata type, metadata flavor Google. And if you are running a GCP machine, you have the same exact impact on that machine as well, right? Same exact impact on that machine as well. You are able to access the credentials or the service account token that's been loaded on that GCP or Azure machine, and you can still do the same thing because of the trusty HTTP 303, right? That's the benefit of 303, right? So this is something that you can do as well. So not only is it just a pure GET request, which is AWS centric, but if your webhook provider allows you to add custom headers, you also have this potential. You have the potential for something like this to happen. Of course, with AWS IMDS v2, I think it has been addressed quite comprehensively, because they require you to do a put request and then do a get the token and then do a get request after it. So it's not obviously that easy to do this, at least without doing an RC in some way. But for Azure and GCP, and I'm sure many other cloud providers that I'm not able to list right now, I'm sure a very similar type of attack is possible even there as well, wherever there is a metadata header. Now, the first thing that one thinks of when they do this is, why not just block list, right? Why not say that if the IP is 169.254 or 169.254, if the webhook consumer gives me a IP like 169.254 or 127.0.0.1 or local host or something, why not just block list it? But then again, the provider, the consumer can set up a domain that says blah, blah, blah.evil.com, and that could be 169.254, and that could resolve to 169.254.169.254. So it's not always that the IP blocklisting approach works, right? So you have to think about it more holistically than just the IP blocklisting approach, because your DNS will resolve to 169 or 127 or localhost or whatever it is. It will work, and the attack can still work unless you have some kind of a DNS proxy, or if you have some kind of an open DNS or something where it will not resolve those local host or whatever blocklisted IP addresses that it actually post-resolution resolves to, right? So that's basically another potential area of evasion of this particular type of thing. We've seen this again. So all of these examples are something we've seen on live systems, which are either they have some kind of vulnerability disclosure or bug bounty program. And we've seen variations of this, right? Some of them, for instance, like Stripe, they're pretty strong. They've done a lot of work on this space. Some of them are completely clueless about this. So it really depends on where you are in the spectrum, right? So it is entirely dependent on where you are in the spectrum. Now, let's talk a little bit about defense before we close the session today, right? The first and the most important defense in this particular case, especially when you're dealing with webhooks, is do not follow the redirect. Okay? Do not follow the redirect. So this, in many HTTP clients like Python and Go, by default follow the redirect. So you have to ensure that your client is setting follow redirect to false, or whatever is the configuration parameter that does not follow the redirect. Because if you follow the redirect, you are going to be susceptible to the whole 303 issue. Now, this is the first and most important control, at least to deal with this particular flaw, or this particular possibility of flaw, right? Do not follow redirect. If you don't follow redirect, this flaw is not going to happen from that perspective, right? So it's not going to happen from that perspective. In addition, to go a little deeper for defense in depth, if you can have a network security policy, again, this is not exactly super easy, because if you have metadata on that endpoint, chances are that you want to use that metadata. So by adding a network security policy that disables access to metadata or something, you may not be achieving it. But if possible, if you can, if it's feasible, think about a network security policy which disables access to a specific set of URLs, or it really depends on what kind of case you have. It depends on the kind of app, the kind of access the app has, and so on. Try and lock down the network security policy, even on your Kubernetes clusters or with your AWS VPC or your cloud VPCs, in Azure or GCP or whatever it is, right? So this is another option that you can do. DNS proxy. Now, this is something that you will probably have to enable in your node itself, where you essentially have a DNS proxy that does checks post resolution, right? Post resolution, it checks whether it's an 169 IP or a 127 IP. That's where you want to check whether something is resolving in a nasty way. So you want to probably have a DNS proxy on the node. This is also an additional mechanism that you can use. Or if the DNS server that you're resolving to is automatically programmed with an allow list, that's great. That's easier to administer. But if you don't have that, then DNS proxy may be a way to think about this as you go along. The other thing is to have a validating webhook URL, which is basically to check whether your URL is legit or not. Again, this has its own limitations because people can evade and bypass this depending on how broad your webhook setup is. IP deny list also is a possibility, but it can be evaded. These are not the most efficient ways to do this, but these are options that you have depending on the kind of external, internal, public-facing, non-public-facing, consumer, non-consumer type of application that you have. So all of these are potential defenses, but the first one is the big one, right? Especially to avoid the whole boomerang effect of your webhook, the first one is the one that will solve a lot of these problems for you, right? So in conclusion, webhooks are a powerful way to integrate your apps with others. Obviously, this is something that we're seeing. You have webhooks all over the place today, and there's a reason for it. It's super easy to use, very convenient, highly interoperable, makes your application much more accessible to a lot of other applications. Also a powerful way to get attacked, right? Because these kind of attacks happen. And in most cases, like I said, a lot of HTTP clients by default follow redirect. So if you have that sort of scenario, you could be potentially vulnerable to something like this. Consider webhooks in your threat model. Now, this is the starting point for everything, right? Now, a lot of people don't think about webhooks when they're threat modeling, right? Or they don't think of the feature webhooks when they're threat modeling. They just put the standard best practices or standard security practices for webhooks like APIs and API keys and HMAC and stuff like that. That's great. Good. No problem. That's a good start. But think about a threat model which incorporates something like this. And if you're a large team or a team of teams where you have multiple teams that are dealing with similar issues, then it's something that you want to enforce across the team. In fact, one great thing that you could do is write a secure default HTTP client or use a secure default HTTP client. By default, that does not do redirect following, that does not do this and that. And there are a bunch of stuff. There are options out there. There are HTTP clients that are by default secure against multiple variants of SSRF. I don't have the exact names right now, but there are on each major HTTP client project typically has SSRF. No, I wouldn't say 100% secure, but at least SSRF hardened HTTP client. So definitely consider having these secure defaults in your development workflow, have your developers use it. It will definitely make a lot more difference to your security posture, not just for this flaw, but for SSRF in general, right? SSRF in general, this will definitely make for a very powerful. So SSRF is the way this happens. So attackers are going to leverage SSRF to do this. So you have to think about that. And look at defense holistically, right? Because yes, you can avoid redirects, but can you do anything more? Can you ensure that there are multiple layers? Because at some point in time, let's say a developer who's not very experienced ends up adding, just using the default library, and that might still cause problems for your application down the road. So these are the things that I can recommend for this particular flaw. And if you're using webhooks, definitely look for these issues. If you're a red teamer or a pen tester, think about this in your next pen test, because I've seen a lot of squishy targets in this space, especially CI systems, APIs. CI is horrible. CI, the track record of most CI systems on this front is pretty bad. We've seen cloud CIs, we've seen hosted CIs that are pretty bad on this front. So definitely think about it. Marketing automation is another squishy target because they redirect to all over the place. And if you're using marketing automation tools, either SaaS or otherwise, definitely bring this up with them or check whether they're vulnerable to this, or if you have permissions, of course, to do that. So yeah, this brings me to the end of my talk. Thank you very much, and thank you for having been a great audience. I hope it was useful. Thank you. Questions? I think I have 15 minutes.
Yeah, sure. Any questions?
Thanks, Abhay, for the wonderful presentation.
Thanks.
Yeah. For example, let's take that Stripe is making a call to the consumer, and consumer asks Stripe to redirect to 303 AWS metadata. Now, Stripe makes call to the metadata call, right? And it gets the response of AWS credentials.
Yeah.
Does consumer receive the credentials, or how does the consumer gets the AWS credentials here?
Okay, good question. So typically what happens is that most webhook providers have a trace, right? So they will store the response from whatever request they make. So if they make a request to a provider and that provider comes back with a 200 response or whatever, or any response, they will store that in its trace. So you can log into Stripe and look at all the traces of those logs or that have been generated from any webhook events that have been triggered from Stripe.
You mean consumer will have a option to get the trace of the webhook?
Consumer is the user of the system, right? So
Yeah.
consumer is a Stripe customer, or Stripe is not vulnerable to this. I'm just using Stripe as an example. Consumer is a Stripe customer. So he's going to log in, they're going to log into their Stripe admin portal and check out the webhook traces on their developer dashboard, whatever.
Okay. Thank you.
That's what you saw with the Docker one also. It's the same thing. The developer dashboard is where, or the admin dashboard is where you saw all of these, logs being generated from those traces. Any other questions? All right. This is definitely a lunch crowd. No questions at all. All right. Thank you very much. If there are no questions, I'm happy to take any questions offline. And thank you very much.
Thank you.